teach you online about the beauty of engineering or the beauty of applied science. If that might be your questions, then I want to tell you that possibly today you met with the right answer. So I'm not predicting, but I'm sure that today you met with the right answer. How are you, everybody who is watching this fantastic program? My name is Olenjolai, Moko TAYAI Losingo. I would like to take this support. Simply just call me Olenjolai. I thank God by His own grace, He has given me a gift of being an engineer. And I thank God by His own grace also, He built in me and He gave me a gift of being a national and international teacher. In these programs or in these institutions, I'm going to teach you all undergraduate students who are studying different programs in engineering and science. I am a Tanzanian and this is our national flag. I love so much my country. How about you? So, ladies and gentlemen, welcome. I would like to take this opportunity, myself and then all the members of OPITO, to welcome our every national and international viewer who is watching this program or who is learning through this program in different aspects of life. So I would like to tell you in advance, I will never let you down. And I would like to tell you in advance, get prepared to be transformed from the previous state into the new phase. And I would like to tell you in advance, get prepared to receive the challenges that I'm going to give you step to step to think it differently. And I would like to tell you in advance, think yourself as a great engineer and great scientist that your nation needs you, and your nation needs you, and your country needs you, and your continent needs you, and the entire your community, your family need a great engineer and need a great scientist like you right now, who is getting prepared in order to reach your achievement. Whether you are learning this content formally or you are learning this content informally, you are only welcome. Myself, I have been a student of formal education and informal education, and I'm still a student of formal and informal education, and I will be a student of formal and informal education. So I understand what I'm saying about formal and informal education. So I'd like to take this opportunity also to welcome all the international and national viewers or students, just I can call you as students or teachers or lecturers, into our online undergraduate Polytechnic Institute of Tanzania, _OLENJOLAIM. As the name implies, we are, from the first word of the name, is called online. So we are providing our contents currently online. So if you want to access our contents, you should be a lover of the internet and you have to see the applications of internet on learning the contents according to the syllabus of your country. So I am a Tanzanian. I'll be focusing and I'll be using the syllabus and curriculum of different institutions, colleges and universities in United Republic of Tanzania. So it's a time for them to learn by using the video, to learn. This is the record of a real and a physical lecture. Wonderful. So let's take this opportunity also to welcome into one of our official YouTube channel where you can receive our contents every day as a daily bread in your mind, which is called the Online Undergrad POLYINSTIT of Tanzania in _OLENJOLAIM. So wonderful. This is a fantastic official YouTube channel where we are contributing different contents in order to mentor, in order to teach and train undergraduate students or bachelor students in other words. When I say undergraduates, it means that bachelor students. I would like also to welcome in one of the departments that called the High Engineering and Scientific Mathematics. Again, I would like to welcome you into the module called the Probability and Statistics. And then, I guess, if you are a second year, these contents are prepared to the second year who are doing Bachelor in Engineering or Bachelor in Science, or we call it, under the perspective of Nacte, called NTA Level 7. I will be focusing on competence-based, not knowledge-based, when I'll be teaching on probability and statistics. And the reference syllabus I'm going to use is Dar es Salaam Institute of Technology. I would like to dedicate this lecture to all my second year undergraduate students who are doing different programs, almost more than 8 Engineering and Applied Science programs at Dar es Salaam Institute of Technology received this gift from Olenjolai. Okay, so like also we'll be focusing on chapter 3. So welcome into the chapter 3, which is called statistic estimations. We'll be combining the concepts of probability that we learned in chapter 1 and 2 with statistic right now. So we'll be speaking about probability statistic, and probability and statistic is actual. These are the concepts that we are using to solve daily real life. Okay, so we are in lecture 4, which is titled as Problems Solving of Interval Estimations of Mean of Populations with Known Variance. So you're welcome into session 4, into lecture 4. But before we go into too much details, because I want to welcome all the new students, new viewers, and give them some few procedures of how to register themselves permanently and access our contents easily as just a single click. So I want to remind you, we have a vision. Online Undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM, we have a vision. Do you know our vision? It might be also your vision because you are part of this online institution. This is the vision that built up in our mind. We have an assignment to teach and train undergraduate students on how they can extract knowledge, understanding, and wisdom from the classroom instructions, combining with the knowledge, understanding, and wisdom that will teach them to extract it, and even as a teachers also teach them to extract it from the Word of God written in the Holy Bible in order to solve real life problems, from the small scale real life problems to extremely large scale real life problems. Right? That is their vision, and you have to remember. The main objective of OPITO, because OPITO is abbreviations of Online Undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolai. The main objective is to teach you how you can think differently and take the classroom instruction to solve real life problems. However, that we have so many specific objectives. One specific objective, we are going to prepare you for your continuing assessment. We are going to prepare you for your testing 2. We are going to prepare you for your makeup testing, which is test 3. We are going to prepare you for another specific objective. We are going to prepare you in order to pass well and even having an excellent performance in your final exam or university exams or end of semester exam. So regardless of how you call it. So if that's the case, for registered students, you don't need, just so you can skip the next part. If it's your first time, you met with Olenjolai, you're warmly welcome. I love you so much. We are here in order to transform your mindset. So let me just spend 2 minutes to give you instructions and explaining to you and just to clarify what you have on the blackboard for you to register in OPITO. First of all, OPITO is abbreviations of Online Undergraduate Polytechnic Institute of Tanzania in square bracket Olenjolai. The first step, if you have an email, then skip the first step. If you don't have an email, create or open a new email. Then the next step, we assume that you have the applications of YouTube. So we ask you to sign in YouTube by using your email. So you'll be asked your username and password. The third step, we ask you to search OPITO in YouTube. So don't write OPITO because it's not there. Just copy and paste our YouTube channel that's called Online Undergraduate Institute of Tanzania in square bracket OLENJOLAIM. Again, you'll see what the round buttons, which for us we call it OPITO poster, with our national flag. Then beside it, you'll see the name of our channel that's called the Online Undergraduate Institute of Tanzania in square bracket OLENJOLAIM. And then you'll see the number of videos that we've already uploaded right now in our official YouTube channel, which is our online school. You see the number of subscribers. Number of subscribers means the number of registered students who will get notifications once we add a new content or a new video in our official YouTube channel. So the fourth thing, we ask you to click the round button. This is just like a welcoming poster. Because even if you go to the Dar es Salaam Institute of Technology, you'll meet with different posters that welcome to the Dar es Salaam Institute of Technology, in parentheses or in brackets DIT. Wonderful. If you go to University of Dar es Salaam, you'll find a poster that giving you information that right now you are in the physical place of University of Dar es Salaam, University of Dodoma, University of St. Joseph, right? So this is our poster right now. So when you click that one, so you'll see the trailer video, you see the horizontal bar, written songs, video, playlist, community, channel, and about. So we ask you that, we'll come back later. We ask you right now, take your mouse, not your mouse, take your mouse and then click this text written subscribe. Just find it. You saw it, and then if you click it, the text will change into subscribe. Once you see the icons of the bell on the right hand side, we ask you to click this bell once. So you'll be given 3 options: all, personalized, and none. So we ask you to choose what in all. So from there, you give YouTube community official permission for them to give you notification whenever we add any new video in our online institution. And the good news, you have to register yourself only once, and there's no registration fee. So the good news, we don't have semester registration. The good news, we don't have registration fee. Wonderful. So answer some other questions. So that's how it's institutions. How comes that the students learn these contents free of charge? Keep that questions, you'll get the answer ahead as we continue. So for you to take advantage of our contents, we create our contents, we create something we call it a playlisting in the YouTube channel. So we use the functionality of playlisting to collect the related videos. So for example, if you click these buttons of playlisting, then you find the playlist written statistical estimation, you'll find collections of all lectures that will teach you about the topic called the statistical estimation from the first lecture to the last lecture. So you learn these contents systematically without jumping and spending much time on the seeking. Again, we know that our contents will transform your mindset and you'll love them and you'll fall in love with high engineering and scientific mathematics. So you will be asking yourself, how can I share this good news with other students in Tanzania, with other students in Kenya, with other students in the United States of America, with other students in United Kingdom, with other students in Australia, with other students in China? Then there's the icons of share. Click that icons of share, then you'll be given the video links that you can send to any students around the world by using any social media. For example, Facebook, WhatsApp, Twitter. You may send it through Instagram, you may send it through email, you may send it through TikTok, you may send it through TAYAI, etc., etc., etc. Wonderful. So thank you very much. Now, our registered students join with the new students and let us go inside the today's session. Okay, so let us start with quick review. This is Olenjolai teaching protocol. Quick review of what we taught you in lecture 3. So in lecture 3, because this quick review will make a link in lecture 3. So in lecture 3, we taught you the concepts that called the first of all, it is called the concept that he called it interval estimation. So we taught you about interval estimation, okay? Interval estimation of what? Of mean. So interval estimation of mean of normal population. This is the title of the session of the lecture 3. Normal population, say with me, normal population. Normal population with known population variance. With known population variance. Why do we add the phrase variance? The phrase known population variance means later on we'll teach you how you can find the interval estimations of the population with unknown population variance. Right? So you have to get prepared. So you have to focus on the concept. And this is one of the subtopics. This is the second subtopic of statistical estimation. We taught you so many concepts and we broke that to us because we had lecture 3A and also lecture 3B. To summarize, we have been dealing with 2 types of populations, finite and infinite population. So we've been focusing on derivations of what? Confidence limit, the general form of confidence limit. Confidence limit, for example, of what? Of infinite population, which is equivalent to the concept that we call it what? We call it probability with no with what? With replacement. So confidence limits of the infinite limit, we say that this one will be given as mean of the sample plus or minus, then we say what? Error. But this error, remember that this is given as what? Mean plus or minus, then standardize the value at the confidence level or at the confidence interval, and then times what? Times mean of sampling distributions of means. So it depends. So for infinite population, if you do remember, for infinite, so simply let me just let's say confidence limit of what? Okay, so let me do this. Amend my confidence limit of what? Of population. So confidence limit of mean of what? Of population is given by this formula. So we say that for infinite population, so we say that the mean of sampling distributions of mean is given as standard deviations of population over square root of the sample size. So it means that simply say that confidence interval, this is equal of the infinite population, is equal to mean plus or minus standardized value at the confidence interval times the standard deviations of population, then over square root of 40 sample size. Another important formula is confidence interval of what? Of finite population. Okay, so this one we told you it is mean plus or minus what? Standardized. So you say that standardized value ZC times what? Mean of sample distributions of mean. So the formula for means of sample distributions of mean is what? Is standardized value times what? It's actual that times standard deviations of population over square root of sample size, and then this one we say that it is square root of 40 population size minus sample size of what? Over population size minus 1. So these are the main concepts that we taught you in lecture series. So today we'll be focusing on solving more problems. We solved the two problems, two examples, example 6 and example 7. No, example 5 and 7. Yeah, did we solve example? Yes, example 6. We solved just example 6. And yes, we solved only example 6. Then we left the homework, which is example 7. And let us start with corrections of the homework that we left it to you. So ladies and gentlemen, we are doing correction of 40, correction of homework 3, which it was example 7 in lecture 3. So the question was stated that refer the data of example 6 above, determine what? Roman A, we have determined the 90% confidence interval estimates of mean, and Roman B, a 99% confidence interval estimates of mean. So that's the process. So to solve this one, we'll be following some steps. The first step, we say that recall the data of what? Of example 6. So in example 6, we found that mean of a sample, or sample mean of the sample, statistical mean of the sample is 19.3. Also, we found that we've been given standard deviations of population is 3. They've been given sample size of population is 10. Okay? It's 10. And then the other piece of information, yeah, that is enough. That's what we've been given. So Roman A, we have to find what? A 90% confidence interval estimate of mean. Wonderful. So remember, again, another piece of information, what the type of populations in example 6, the type of 40 of population. So the type of population in example 6, we told you that it's infinite. So you'll be using the formulas of confidence limit of infinite population. So it's infinite. So that's the first step. Okay? So if it's infinite, so we go to the second step. So second step, we have to recall it. Call the formula of what? Formula of finding confidence interval CI of 40 of confidence interval of 40 of mean of infinite or for infinite population. Okay, so we told you that the confidence limit will be obtained from the statistical mean plus or minus standardized value at a critical value or at the confidence level times what? Times mean of the samplings, means of the sampling distributions of means, which is for infinite population, it's a ratio of standard deviations of population over square root of sample size. Okay, so that is the general formula. So you're being given the statistical mean in example 6, you'll be given the standard deviation of population, you'll be given the sample size of population. What we don't know is just what the standardized value. But remember that you'll be given what? Be given confidence. This we call the confidence level. In this lecture, I will teach about confidence level. So the confidence level in Roman 8 is 90%. So remember that this confidence level simply say that this is probability of what? Probability of 0 less than or equal to Z. Okay, yeah, so you say that 0 less than or equal to ZEC, then this is less than, 0 less than or equal to Z, less than or equal to ZEC. This is equal to what? 90%. This is equal to what? 90 over 100. So it means the probability is equal to what? 0.9. So to find the standardized value, I told you the technique, right? So it means that the steady state, find what? Find ZC corresponds to what? Corresponding to 0.9. So I taught you a simple technique. There's no need for you to claim about the values I gave you in a table of session of lecture 3. So I gave you the simple principle. You should have your table 4.4 as statistical table as a reference. I have mine. You should have your scientific calculator, and then let us go into business. So if you sketch, okay, so to find this one, so you say that sketch normal distribution. Sketch normal distribution. Okay? Sketch normal distribution. So this is what? Okay? So you say that this is negative infinity and this is positive infinity. Okay? So this is what? So negative infinity, positive infinity. So this is 0. 0. Okay. So 0.9, it will take this space. So this is negative ZC. And then here we have also the positive ZC. And the area or the probability of this region is 0.9. Okay, so remember that 0.9, and then you have some remaining parts. So 1 minus 0.9, remaining 1. 1 over 2, we get 0.5. So the total area of the shaded region, this one is equal to 0.5. Is equal to 0.5, and this one, the area of this region is 0.5. Okay? So if that's the case, so you have 0.5, 0.5, that is good. Okay, so we say that Wonderful. So if that's the case, so we like to find ZC. So the total area from 0 to positive infinity is 0.5. 0.5. So we say that to find it, so you say that probability of 0 less than or equal to Z less than or equal to ZC, this is equal to what? This is equal to 0.5 minus the shaded. Oh, this is 1/2. Oh, excuse me. I made a mistake here. So we have 0.1 because if you take 1 minus 0.9, then the shaded regions has a probability of 0.1. So because you have the first shaded regions and the second shaded region, so this will make 0.05. So the total area of this shaded region is 0.05, and this one also, it is what? Its total area is 0.05. Okay, so if that's the case, you say that you have 0.5 minus what? 0.05. So probability of unshaded region from 0 to ZC less than ZC, this is equal to what? Is equal to 0. So if you substitute is equal to 0, means 9. So it will be 10. 10 minus 5 is 5. Then here remains what? Remains 4. 4 minus this one is 0.4. So this is the probability. We have to use the probability and the statistical table to find the value of C. Okay? So we go into the first step. This technique can help you to find confidence limit of any confidence level, of any percentage that will be given. Those that we gave in the table in lecture 3 are the common one. I know some teachers, they teach students to cram, but I don't have an assignment of teaching you to cram. I have an assignment to teach you to understand and love and apply. So the first step, we say that now use what? Use table 4.4, okay, to find what? To find ZC corresponds to 0.45. So take your table right now. It's time for your table. Okay, so you remember the table that I taught you in lecture 2 and lecture 3. Yes, in lecture 1, lecture 2, and lecture 3 of normal distribution. So we'll be given a probability right now. We have to find its corresponding ZC, right? So it means that we have to find 0.45, and then we have to rate its standardized value. So you have to go into the columns and rows of probability. So 0.45. So 0.45, you have to find the first one. So the first one is 0.4495, and the next one is 0.505. So ZC, it will be an average between ZC, which gives us 0.4495, which it is 1.64 plus 1.65, then divide by 2. Okay, so this will make 9, then 6 plus 6, it will make 12, then 1 plus 1 will make 3. So over what? Over 2. So then you see, this is equal to what? So 2, it is 1, then 0.6, then 4.5. So this is the value of 40 of standardized value at the confidence interval. So you have found it. So if you have found it, now you can find the confidence limit. Okay? So suppose that this is first formula. Okay? So we go into the fifth step. So you say that substitute values that we see, sample size, standard deviation, and mean denote in the question 1 above. Okay, so substitute ZC and standard deviation in the question 1 above. So here we have confidence limit. So it's equal to statistical value, which is 19.3 plus or minus. Then the value of ZC it is 1.645. Even you read from the table, you'll find the same terms, standard deviation of population, then over square root of 40 of 10. So right now you have to use what therefore confidence limit is what? Confidence limit of what? Of 90% is, so you have to take your scientific calculator. In case you lost your scientific calculator, we don't have any, you can order original scientific calculator of Casio function 991 MS from online undergraduate library of Tanzania. So you can order this scientific calculator, just send your message of order through that telephone number 0759745331. So my dear students, we are going to do the computation. So you have 1.645 times what? Times 3, then over under root of 10. So plus 19.3. The response is what? Is 20. Oh, excuse me, don't add the 19.3, excuse me. So it means that we have an interval, we have a statistical mean and error or tolerable error. This is 19.3 plus or minus 1.56. You may put in 3 or in 4 decimal places, 5. So this is the response. Or you can put as interval, you can say the confidence limit lies between what? 19.3 minus 1.5605 and the 19.3 plus 1.5605. So check your answer. If you succeeded to get the same response, then congratulations. You are about to understand the concept of confidence limit or the concept of interval estimation of mean of populations with known variance. Then Roman B, okay, so you follow the same procedures. Okay, so Roman B, you've been given what? So Roman B, we have been given a 99 confidence interval estimate. So we have deal with a 99 confidence interval estimate. So you follow the same procedures. So to solve Roman B, no need for you to repeat first state because it's the same question. No need for you to repeat the second state. So you have to go straight forward on the third state. But because the same questions, we say that we ended in OT, we ended in the fifth state. So you go for the sixth state because I want to do correction for you. You have to be confident enough because this is a very important content for test 2, very important content for final exams, very important content in postgraduate studies, very important contents in applications or different applications of life. So the sixth step we say that find ZC corresponds to what? 99%. So the probability is 99%, or in other words is 0.99. That's the probability. Okay? So if that's the probability, so you say that what? Sketch the normal distribution. Sketch the normal distribution. So to sketch the normal distribution, then here it is. So this is 0, and then this is a region, unshaded region, where the area, so we have shaded and unshaded regions. Okay, so this is unshaded region, so here area is equal to what? 0.99. Okay, so if you take 1 minus 0.99, you get 0.01. So 1 minus 0.99, you get 0.01. So if you divide by 2, you find that these shaded regions, the area of each shaded region is 0.005. So the area of this shaded region is 0.005, and the area of this shaded region is 0.005. I know that many teachers and even yourself, you are expert on cramming the values. So I have mentioned the value of ZC corresponds to 99%, but that's not my task. I just showed you, but I'll teach you the techniques that engineers follow on determining the standardized value at the confidence level. I believe that you're enjoying our session, you're enjoying lecture 4, and tell us in the comment sections if you understand what we are teaching you. Tell us in the comment section, please. Just communicate with us in the comment section if you understand what we are teaching you. If you don't understand, ask your questions. If you are seeking for any kinds of the help, ask a question in the comment section. We visit the comment sections of each lecture. Okay? So ask your questions and then give us feedback whether you understand, you enjoying this content, from which institution, from which college, from which university, from which country. You're enjoying from Tanzania, from Nigeria, from South America. So you have to tell us in the comment section. So from there, we know now how. So remember that this is sorting ZC corresponding to 99%, and this is negative ZC corresponding to 99%. Okay, my dear students, if that's the case, we say that now to find, so it means that simply by using table 4.4, we can find probability, we can find the probability or between 0 and ZC. Probability of the area under the curve, or area under the curve between 0 and the ZC. So this one we find as what? So probability of 0 less than or equal to ZD, less than or equal to ZC. This will be equal to it. So the area under this curve. Okay, so the area from 0 to positive infinity, the total area or the symmetrical area is 0.5. If you substitute with what area of the shaded region, it's 0.05. So you say that probability of 0 less than or equal to ZD, less than or equal to ZC, this is equal to what? So 10 minus 5 is 5. Then we have what? 9. Wait. So it means that this subtraction is what? It is 0.500 and then say 0.005. So 5, 9, then 4. Okay. So 4, 0.2, so 0.495. So that's the probability. So the seventh step, we say that use table 4.4 to find ZC corresponds corresponds to what? Corresponds to probability of 0.495. Okay, so take the table 4.4, go to the columns and rows of probabilities in 4 decimal places and find the probability equal to 0.495 or near to 0.495, because it should be in 4 decimal places, then you add 0. So it is 0.49, 0.49, 0.49, 0.4, 0.4, 0.4901. So you have 0.4898 and 0.95. So 0.95, 0.495, 0.495, 0.4949, and 0.4951. So you see, it means that 0.4950 is lying between 0.49459 and 0.4951. So the corresponding, so it means that now ZC we can find as an average of 40. So 0.4949 is what? 2.57. 2.57 plus 2.57. So we have what? 0.4, 0.4, no, 0.4995. Yes, 951. So it is 2.57 plus 2.58 divided by 2. So 8 plus 7 is 15, we keep 1. 5 plus 5 is 10, and 1 is 11, we keep 1. And then 2 plus 2 it is what? 5. So 5.15 over 2. So then this is 2, right? So 5 over 2 it is 2, we have 1. So 2.5. So 5, and then that one's have 7, 5. So it is 2.575. Yeah, it is in between. That's the value of that C. Okay? So afterward, then we say that we go to the last step, which is the eighth step. The 8th step, we say that now substitute ZC, so we can call it maybe ZC2, or ZC it is now. ZC, sample size, standard deviations of population, and what? And the statistical mean in what? In equation 1 of what? Of example 7a. So we've been looking at the confidence limit. Okay, confidence limit. This is given as what? The value of x bar, it's 19.5 plus or minus what? The value of ZC is 2.575 times what? Standard deviation, which is 3, divided by what? Divided by square root of what? Square root of 10, which is sample size. So if you do your computations, you can use your scientific calculator. Then the response for Roman B, now we say that confidence limit is what? 19.5 plus or minus. Just take your scientific calculator. If you don't have an original scientific calculator, you may order in our online undergraduate team library of Tanzania, right? Online undergraduate library of Tanzania. You can order the original scientific calculator. So you have what? You have 2.575 multiplied by 3 then the response we divide by square root of 10, and then 30. So the error is 2.44 in 3 decimal places, 3. So this is the response for Roman B. So check your solution. Check your final response. Check your solution, because here we have solution and final response. Always final response has a small, has a low marks compared to the solution. So check your solution and my solution. Compare my final responses and your final responses. And then tell me in the comment section that, sir, I made it. And congratulations if you have succeeded to solve homework 7, homework 3, example 7, Roman A and Roman B. And you have to tell yourself, I'm about to understand the concept of interval estimation of mean of populations with known variables. Okay, ladies and gentlemen, right now, I would like to take you into the next example. Okay, the next example. I have to teach you to different techniques of solving different problems. Okay, we spend so much time on doing corrections, but it's a part. I'm building something in your mind. So, ladies and gentlemen, receive example 8. And this example 8, it's a concept question. Most of these statistical questions are weighted problems, so you have to be familiar. So the question says that in measuring reaction time, a psychologist estimates that the standard deviation is what? 0.05 seconds. How large the sample? How large the sample of measurement? How large the sample of measurement must be heated? Must be heated. Or must heated in order, so it's a question mark, in order to be Roman A 95% and what? And Roman B 99% confident. That the error of his estimate will not exceed 0.01, so 0.01 second. So that's the question we have been given. So make sure that you have your table, make sure that you are writing, and make sure that you have your scientific calculator beside you. So let us read the question. In measuring reaction time, a psychologist estimates, so you can pause, okay, take a pause. In a measuring reaction time, so this is the measured reaction time, so it means It's a research made to the reaction time. A psychologist estimates that the standard deviation is 0.05 seconds. A psychologist was doing a certain reaction, so he was measuring the reaction time. So what is this standard deviations? Is it the population standard? Is it standard deviations of population, or is it standard deviations of sample? This is standard deviations of 40 of population. That's the first sentence. Then the second sentence starts with how large the sample of measurement must he take in order to be. So it means that we have been asked to find what is sample, how large. So there means that means the size, the sample size. How large the sample, right? Must he take in order to be 95% confidence and 99% confident that the error of his estimate will not exceed 0.01 seconds. Remember that S is standing for seconds. Okay, so you have the standard deviations in seconds, and you have the estimate, the error estimate of mean of population, which is its unit is second. Probability does not have unit, but other physical quantities have have unit. Are you ready to solve with me? You can pause the video and try to solve this question on the rough paper, and then you come to check my solution. Remember that I'm using the technique called the active digital learning, where students are centered in this journey of learning. So the process means you have to be faithful to God who is watching you and to yourself. How? It means if I ask you to pause and try the question, just you have to do that. Right? And don't say that Olenjolai does not see me. Right? Or Olenjolai is far from me, so he is not seeing me right now. That is not a good method of learning and mastering higher engineering mathematics and higher scientific mathematics. So you can pause the video and try on the rough paper. Then come and check the right collection, the right solution. Then you compare, and then you identify your mistakes during the practice or during the learning time, that you will never repeat them, or you will correct them in order not to repeat them in examination, or not to repeat them in solving real life problems. Okay, so the first step. So the first step, we say that the given data. Okay, so you say that list of given data. What are the data we've been given in this question? The first one is standard deviations of 40 of population, which is simply this one. So we've been given as 0.05 seconds. Then the second information we've been given is confidence level. So this we call confidence level. So confidence levels. So you've been given confidence levels in Roman A and confidence level in Roman B. So you have two confidence level. The first one is 95%, and the second one is what? It's 99%. And then say be given the error. So remember that his estimate will not exceed, so that the error of his estimate, of which population parameter, but this one is of which sample parameter, it's mean. So means for that case, we have been given error of mean estimate is equal to 0.01 second. 0.01 seconds. Seconds. So those are the information we've been given, but we are looking forward how large the sample of measurement must he take. So it means we are looking for the sample size. So sample size is L. This is what? Required. So this is required. Okay? So you go for the second step. The second step, we say that you have to record what? The general formula. The general formula of what? Of confidence limit. Confidence limit. So what the general formula of the confidence limit? So the general formula of confidence limit this is equal to what? Statistical mean plus or minus error of 40 of mean. Okay? The given population is infinite because the population size is not given. We may ask the sample size. So in the case now, we say that error, so the second formula, error of mean, this is generally given as what? Standardized value at confidence level times standard deviation standard deviations of sampling distributions of means. This is called the standard deviation of sampling distributions of 40 of means. So if that's the case, we say that, okay, so this is the first equation, this is the second equation, and this is the first equation. So from there we say that mean of sampling distributions of means, this is equal to what? Is equal to standard deviation over square root of sample size, and this is 40 for infinite population. For infinite population. So ladies and gentlemen, we say that error of mean is equal to standard value at confidence level times standard deviation over square root of 40 of sample size. Okay, so what are we looking? We're looking for the sample size. So you have to multiply by sample square root of sample size to both sides. So this one and this one are cancelled. So you have square root of sample size times 40. Remember this, I wrote these questions as a concept because we are teaching or we are building a new concept in our mind. So we are looking for 40 for standard deviation. So you have to divide with error to both sides. So on this side, you have to divide with error to both sides. So on this, on the left hand side, you have what? Square root of sample size, which is equal to what? ZC times standard deviation over n. So we have to square both sides, left hand side and right hand side. So we are deriving the formula that will help us to find sample size of any given population or of any given infinite population. So from there means if you square on both sides, we have the sample size now is equal to what? Is equal to standard value at C times standard deviation of what? Over error or tolerable error of mean square. So this will make your equation 3. So remember this formula for the rest of your life. Very important formula. Remember this formula to help you to solve many problems about interval estimations of mean of population or of normal populations with known variance. Okay, so if that's the case now, we say we have been given error, we've been given the value of this one. So we like to solve from the confidence level. I will teach you in the next lecture what it means of confidence level. Confidence level For this case, it is what? 95%. Okay, 95 what? 95%. So it's 95%. So if 95%, we have to find it. So find ZC corresponds to what? Correspond to 95%. So we say that refer example 6 of lecture 3, right? Of lecture 3. Yes, of lecture 3. We did this business and we found that ZC correspond to 95% is 1.69, if I'm not mistaken. Is it 1.69? Yeah, 1.96. Don't write this sentence in what? 1.96. Don't write this sentence as refer in exam, right? This is, we use this language only in lectures because we have already taught you how to find ZC corresponding to 95%. So it means that for you, you have to pause the video and do as a quiz to find ZC correspond to 95%. Okay? So if that's the case now, we have the formula, so it means we go into the third step. We say that what now we can find value of population of 40 of sample size. So the value of sample size, this is equal to what? Is equal to ZC. What is ZC? ZC, it's 1.96 multiplied by what? Standard deviation. What the value of standard deviation? The value of standard deviation is 0.05 seconds of what? Over error. Error of the mean estimate is, we are given 0.01 seconds. So, but what is square according to the formula? Means substitute the values into equation 3. So seconds and seconds cancel. So you can use your scientific calculator to compute the expression. So you have 1.96. In case you lost it, the scientific calculator should not be confused. Just visiting our online undergraduate library of Tanzania, so you can order original scientific calculator that will use for more than 3 years. So it means that this is 96.04. So in other words, you say that sample size, so remember, so not this one. Sample size is a physical thing. You cannot choose 96.04 people. We used whole numbers when you're dealing with things. So not before. Sample size is a whole number. So it's not just a fraction. So for that case, you can say that sample size, if you approximate, it's 96. So therefore, means that how large the sample of measurement. So we say that the sample size, therefore the sample size, this is the response for command A. The sample size of measurement of reaction time is what? 69. So this is the final response. You can pause the video and then copy the notes if maybe you didn't finish to copy. So you can copy before I start to clean the blackboard, because I want to leave the question there. So we have Roman B there. So you have Roman B. So it's 99% confident that the error of this estimate will not exceed 0.01. According to my experience of teaching and probability and statistics to undergraduate students for more than 7 years, yes, for more than 5 years, this is one of the most challenging part to many students, but it's a part which contributing so many questions in any exam. So that's why that I'm solving. So after I finish to solve example 8, I will leave the homework for you. And then I will have also lecture 5, when I'll teach you about how you can solve more problems on the same concept. And then lecture 6, I'll teach you about interval estimations of population proportion. Okay? So we are in what? So we are in example 8b. Okay, example 8b. So example 8b, we'll be given the confidence level of what? Of 99, right? So we have to go straight for the into it. Oh, so this is first step, right? Excuse me, this is the first step. So the third step is here. Third step is there. Okay? So you say that you have to go to the fifth step. So the fifth step, which is a quiz for you, find that C corresponds to what? Corresponds to confidence level of 99%. So we taught you how you can find it. So that's why we're giving you a quiz if you remember the procedures that we followed. Don't read from the table, please. Try your level best to use the normal distribution table and the normal distribution curve. Okay? So if you refer example 7, we find in example 7, Roman B. So we found that at C it is 2.58. At C it is 2.585 if I'm not mistaken. Okay. Even that one is fine. Okay. So that is at C. But we can prove from the table. We can prove it from a statistical table. So 0.9, so 2.58. All right. So it is 0, it is what? So 2.57. So in 2 decimal places, it's estimated in 2 decimal places, but we use the previous steps. Let's see, is equal to 2.575, which if you are estimating 2 decimal places, this is equal to 2.558. Okay, so that is ZC. Because the standardized value in table 4.4 is what? Is given in 2 decimal places. Okay, so if you have the C, then we go to the 6th step. The 6th step, we say that, okay, so now, so the substitute standard deviation, error, ZC, and what? And ZC in what? In equation 3 above. So you say that the sample size, this is equal to what? ZC is what? 2.58 multiplied by what? Standard deviation. What is standard deviation? Standard deviation is 0.05 seconds. Over what error? What is error? 0.01 second. So second and second cancel, square. So use your scientific calculator to do that computation. If you have lost it or you forgot it, or you have given to a young brother, worry out. You have 2.58 times what? 0.05 tens of what? 0.01. Is 2.58 times 0.05 over 0.01. And then we have to square. So the response is what? 166.41. Remember that sample size is whole number. So if you approximate, it's 166. However, that we do over estimation, over approximation. So if you have a number, if you have a whole number in the first decimal place, in statistics we do over estimation, not underestimation. So it means that simply the sample size will be greater than 166, which is the next whole number after 166 is 167. So B say that the sample size of measurement is what? Is 167. That's the response. Okay, so ladies and gentlemen, I'm about to end lecture 4. So before I end lecture 4, I've given you quizzes which I call them try it. Let me give you now a question for your private practice or group discussion, right? You may solve these questions in group, or you may do this homework in group, or you may do this homework as individual work. Example 9. This is homework. Homework what? Homework 4. It's not a difficult question, so write it quickly and then solve it. A large population is normally distributed. Large populations is normally distributed with what? With a standard deviation 0.12. A random sample will be taken from this population. And the sample mean will be calculated. So you are still giving will be calculated. The sample mean will be calculated. So a large population is normally distributed with a standard deviations of 40 of population 0.12. A random sample will be taken from this population and sample mean will be calculated. So we require Okay, we require at least 98% confidence that the true population mean we require at least 98% confidence that the true population mean will be within plus minus 0.05 of the sample assume there is no systematic error. Assume there is no systematic error. Assume there is no systematic error. What sample size is required? What sample size is required? What sample size is required? That's the question we have. Everything is clear. Read the question clearly, understand. Don't panic. Love statistic and probability. Love statistic estimation. So the question read that a light population, so let us read together. A light population is normally distributed with a standard deviations of 0.12. A random sample will be taken from the populations and the sample mean will be calculated. We require at least 98% confidence that the true population mean will be within plus or minus 0.05 of the sample mean. Assume there is no systematic error. What sample size is required? What sample size is required? What sample size is required? Ladies and gentlemen, if you've been managing to do this question, that will be the end of lecture 4. And you have to submit your homework in the comment section and give me the feedback whether you have succeeded to solve the homework or you didn't succeed. So I would like to say that this is the end, and I would like to invite you in the next lecture, which will be lecture 5. I'll be teaching you about problem solving, and even I'll solve some questions from the past papers, from the tested tool of the past papers of the Restaurant Institute of Technology and some other institutions or colleges, and also I'll solve some questions of this concept of interval estimation of population mean for population, okay? Interval estimations of mean of population with known population variance. So that's what we'll be teaching you in the next lecture. Don't miss it. And then lecture 6, I will teach about the interval estimations of about proportion, and then I will continue to teach you about other concepts. In the next lecture, make sure that you have your exercise book, you have your pen or your pencil for drawing the curve, and also you have what? You have your scientific calculator, you have your table 4.4 in order for you to understand on how we solve these problems. So I love you so much. I believe that you've been enjoying the way that all the techniques and different ways that we've been teaching you, and I believe that your mindset has been transformed from hating mathematics for the engineers or scientists into the next phase of loving and making good friendship with probability and statistics. I want to tell you once again, one of the branch of mathematics that we apply in our daily life as a human being, and even in designing different systems such as electronic system, is probability and statistics. So learn these contents with a broad mind, with a wide mind, with a high focus. Don't learn it and then check the environments of failure mathematicians or failure engineers who fail to apply mathematics in their daily life. And then have perspective about their country. Maybe in Tanzania, nobody has applied this concept. That's not true. When you go to the postgraduate studies, you need this concept in order for you to navigate safely in your journey. This is Olenjolai from the beautiful country, Tanzania. I would like also to invite you, in case you feel from your heart, you want to offer a feeling Thanksgiving in order to share with me and share with other alumni of Olenjolai and share with other students, parents, guardians who would like to offer their feeling Thanksgiving to God through online undergraduate Polytechnic Institute of Tanzania in square bracket OLENJOLAIM. You may do that by using that telephone number, written Thanksgiving offerings or Sadaka in Swahili. You may send through the telephone number 0759745331 and registered name is Olenjolai TAYAI. And I want to tell you in advance, your feeling Thanksgiving will be used to pay the high running cost in preparations and productions and transmission and distribution of videos of undergraduate level in this department and even in this module in order to impact life of present and future generation. I want to leave a challenge to you. Then after you understand this information, take this as a challenge. Sit aside, sit alone, and then think, what the real life problems that I can solve by this information. Tell us in the comment sections whether you understand or you don't understand. Give us the feedback in the comment section. As I said, we read it. So may God bless you and keep you until we meet in the next session. Enjoy. Hope it all.